All right. So yesterday we talked about, or sorry, the day before yesterday we talked 9-2 stuff, which was called arithmetic sequences, which were, if we put them on a graph, it'd be linear stuff, kind of repeated multiplication, or sorry, repeated addition. And so today we're going to talk geometric sequences, which on a graph would be nonlinear. The learning target is basically the same as it was for arithmetic sequences. We want to be able to, figure out a formula to describe a sequence and use said formula to, find the nth term of a sequence. All right. So just definite. As far as the definition goes, it says here that a geometric sequence is a sequence where the ratio between consecutive terms is constant. The ratio between the consecutive terms is called the common ratio, R. So remember that would be like our common difference on an arithmetic sequence. All right. So an example up here. Does anybody see what are we multiplying by to get from 4 to 12, 12 to 36, 3, right? So yeah, times 3. So that would mean that R equals 3, and then we already know what A sub 1 means. That's the first term of any sequence. So for this one, A sub 1 would be 4. We'll talk about how we can use those to make our rule later. All right. So looking at A, well, the directions for example 1 are identify whether or not it is a geometric sequence, and if it is, then what's R? Okay, so some of them are kind of obvious, like A. We can see that 3 times 4 is 12. 12 times 4 is 48. So this would be a yes, it is a geometric sequence where R, being the common ratio, is 4. All right. The next one is not so obvious, right? So we can figure it out by working backwards and doing division, okay? So let's do, like if this were an arithmetic sequence, we would do like 24 minus 16, or 36 minus 24. Here we do divided by, right? So we're going to check what's 24 over 16. That would be 1.5 or 3 over 2. And then 36 over 24 is also 1.5 or 3 over 2. So like I said, that one's not as obvious, but that tells us that this is a yes, where R equals 1. So no, it cannot be. So on this one, like we do, like if we're looking at B, for instance, the first one would be a +8, the next one would be a +12. So the question was there, could it be arithmetic and geometric? And the answer is no, it's one or the other. So like I was talking earlier, like arithmetic sequence on a graph would be linear, and a geometric would be nonlinear. So those won't ever be the exact same. And then we look at C. So on C, well, 3 times 2 would be 6, and 6 times 2 would be 12. So that would be a no, all right? And we could just say that 6 over 3 is not equal to 9 over 6. So this is a no. But it is, you might notice, there is a pattern, right? We're counting by 3, so that is an arithmetic sequence. But as far as what we're being asked, we just say no. Okay? Any questions before I have you guys try the next 3? All right, so try D and F. I will call on you, so feel free to check answers with people around you. Feel free to ask questions if you have any. But I'm just going to kind of make sure you're getting what we're doing so far.
Mr. Jenkins,
Yes.
we can't see D because of the timer.
Oh, yeah, you're right. Sorry. Yeah, and the notes, guys at home, are, thank you for that, Cole. And the notes, if you guys ever want to print them out, are always attached. But yeah, sorry about that. Cole, who are the Ravens going to go after today?
I would really hope we draft Rashad Bateman.
Who?
Rashad Bateman, he's a wide receiver.
Okay.
That or trade our picks to go higher.
My Dolphins are going after a receiver with their big pick too, so see how that goes. All right, Caroline Essex, what'd you get for D? That would be correct. No, you do ×2 first and then ×5 next, so that would be a no. Or you could say 10 over 5 is not equal to 50 over 10. That's another way to see it. Riley, what about E? All right, agreed. And what's R? All right, very good. So I want you to notice there that, if R is negative, how you get that every other, positive, negative thing going on. So that's always going to happen with these. All right, if R is ever negative. And then Chase Rogers, what'd you get for F?
I didn't get that
one. All right. Cole Robinson, were you able to get F?
No, I wasn't able to get F.
Okay, what about Reagan? No? Anybody have it? Madison?
I said yes, and I thought
So it's not going to be 1/3. That's all right, though. Caitlin, what was it? 3. All right, so obviously this one's a little bit more difficult computationally. So, it's definitely not obvious to the eye. So then it's like, you could think of this a couple ways. If you just wanted to try to plug it into your calculator, remember for a fraction, well, there is a fraction key, so you could use that. It's under math, I think. Or you can go 1 divided by 27 in parentheses divided by 1 over 81. So that's how you could do it with your calculator to come up with 3. Or you could just remember what what it means to divide. So like if I do 1/27 divided by 1/81, then that's basically 1/27 times 81. So 81 over 27 gives you 3. Whatever, but probably easier just to type it in like I just did. So we do get R equals 3. Does that make sense? Any questions before we move on? All right, moving on then. Okay, so in example 2, we want to just find the next 3 terms. So to find the next 3 terms here, we've got to find R first and then just use our calculator from there. So looking at A, that's one of those probably obvious ones. We can tell that R equals 2. We're doubling every time. So A sub 4, which is the 4th term, would be 60 times 2, or 120. A sub 5, 120 times 2, or 240. And then A sub 6, 240 times 2, or 480. You don't necessarily have to write out that notation like I did, A sub 4, A sub 5, A sub 6, but I just want to remind you that that is the notation we use, okay? Let's just do maybe one of the next two. So B is maybe a little less obvious. Can anybody tell me what R is on example B, Madison? So I think you're dividing backwards is maybe what you're doing, because you did the same thing on the other one too. So you do second divided by first, which would give me what? Negative 1/4. Negative 1/4.
I think we can do it. I don't know.
Oh yeah, just doing it in your head. Yeah. So yeah, you got the right idea with the 4, but yeah, if we're decreasing, that's going to be, you know, a fraction. All right. So now we'll just use our calculator from there. So to find the fourth term, we go from the third term, negative 7.5, and just multiply by, I'll just type that in as negative 0.25. So 1.875. And just, I'm going to hit times negative 0.25 again. And what we're going to see are some pretty big decimals. You can write all those out if you want. I'm just going to round. So we'll say that's about negative 0.5. And then times one more time, negative 0.25 is going to be about 0.1. So again, notice the alternating signs there. We go from positive to negative, and that continues on. All right, so we'll just skip C if you guys are okay with that. And so we'll kind of consider next. What if I ask you to find the 8th term of the sequence? Like, think about that one we were on. Or what if I ask you to find the 108th term of the sequence? So what we were just doing in example 2 is basically, you know, using what we call a recursive strategy to get the 8th term. We'd need to know the 7th term. To get the 108th term, we'd need to know the 107th term, right? So there's got to be a better way. So now we get into this explicit formula, which on an arithmetic sequence, that's where we end up with like an mx plus b kind of formula. So now we're going to do the same thing for this. All right. So let's skip to the back side. And some of these text boxes and stuff got out of place. You'll see some things are out of place. So I'll try to fill in the blanks for you. So basically, this is what we want to use to make an explicit formula for a geometric sequence. So this is one of the main things from this lesson, is that guy right there. Okay. So A is obviously, like I said, a formatting error there. So what we're going to do on A is find the 8th term of this sequence. So I'm going to just copy that down, 6, 12, 24. Dot, dot, dot. Okay, so instead of finding the 4th and then the 5th and then the 6th and then the 7th and then the 8th, we're gonna use some algebra. Okay, so we know that a sub 1 is the first term of any sequence. That's the same thing for an arithmetic or a geometric. So in this case, it's going to be 6. And then we also need R, and then we're kind of set. So this is one where pretty obvious. We're doubling every time, so R equals 2. So based on that, my explicit formula is going to be a sub n equals 6 times 2 to the power of n minus 1. 6 times 2 to the power of n minus 1. And now we're going to use that to find a sub 8, which would be the 8th term in the sequence. So that would be 6 times 2. I'm not going to write 8 minus 1. I'm just going to write 7. So 6 times 2 to the 7th. And so we would just use our calculator from there, right? So I'll just type that in. 6 times 2, caret key 7. is 768. So we can skip a lot of steps by using the explicit formula. Okay, yes? So how did we get the exponent 7 was the question, right? So we always, if it's n minus 1, right, and 8 is our n, so we just take 8 minus 1 to get 7, okay? So it's n minus 1, n is 8, right? So that makes our exponent 7. Does that make sense? All right, very good. All right, so let's do one more together, and then I'll have you all try a couple on your own. So looking at B, we would have a sub 1 is 4. R is, what is R? Just blurt it out if you see it. 3. So my formula then is going to be 4 times 3 to the n minus 1. Then we use that to find a sub whatever, right? In this case, they want us to find a sub 10. So in my calculator, I would type 4 times 3 to the what? To the 9th. So we get 78, 732. And we know with that exponential growth curve, right, they do start to increase exponentially, right? So they can get big fast, okay? Any questions before I have you all try the next couple, C and D? Everybody with me? All right, go ahead and try those. C and D. Let's see. All right, so I think people at home can see everything they need to see then. On C, they kind of list it out like a sequence. On D, they give us explicitly what's A sub 1 and what's R. And the issue you're going to run into on these is kind of the sign. So you have like R is negative on both of these. So just be careful with the sign. And I'll give you some tips after you try. All right. So Leah, I'm going to go to you for C. What do you think on C? All right. How many people got 0.5625? All right. So does anybody disagree with 0.5625? Yeah, so this is where the signs come into play. So you saw, I think more people had positive than negative. So it's the mistake that I was kind of planning on you making. But let's just consider this, okay? and I'll tell you how to not make that the sign error. So just kind of big picture wise, just look at the signs of our first three, right? We can tell that as far as the negatives go, our first term is negative, our third term is negative. So that means that it's going to follow that every odd term is going to be negative, right? So if I'm finding a to the seventh, then it's going to need to be negative, okay? So that's one way to see it. But here's how you don't make that mistake. And I would even maybe write this down. If R is negative, use parentheses. And I'm talking about it, like with your calculator, okay? So if you weren't able to come up with the 0.5625, it was, our formula was A sub n equals negative 36 times R, which is negative 0.5, or negative 1/2 to the n minus 1. So that's the formula we're using, right? So to find A sub 7, this is how it should look typed in. So negative 36 times, and again, when you have negative, you put that in parentheses, and it'll do the sign correctly for you. So negative 0.5 to the whatever. We're doing the sixth. So there it gives you a negative. Whereas if you just type in negative 36 times negative 0.5 to the 6, it's going to give you positive. It will give you positive every time there. Okay, so just a reminder. Any questions on that? All right. And then looking at D, Chelsea, were you able to come up with what the 8th term is on D? All right. How about Logan? D. 384 is correct. Very good. So notice it's positive, not negative. So there you go. Anybody have any questions? Anybody want to see that one? Yeah? Okay. So, here they give me A sub 1. Here they give me R. So A sub n is going to be equal to negative 3 times negative 2 to the n minus 1. So that means to find A sub 8, I'm going to type negative 3 times, and I'm going to use parentheses because I have a negative base here, raised to the 7th power. So there you go, 384. Does that make sense? Yes, Lexi. So it wouldn't be negative. So think, and again, just think about the sequence here, right? So our first term is A sub 1, right? So that means that if they alternate, then then the third term is going to be negative. The fifth term, right? Every odd term would be negative. So every even term is going to be positive, right? Yeah. So anyways, but if you think about what's on my calculator there, just as far as the signs go, if you take like a negative base to an odd power, that's going to give you a negative. So we end up with a negative times a negative, which gives us a positive. All right. But yeah, I would just say if you don't want to get too hung up on the negative positive thing, just use parentheses when you type it in. That's going to be the biggest thing. Okay. All right, so let's just, example 4 is only asking us to write the formula. So I'm going to skip over those for now since we've already done that. But those are on the notes. So if you want to try those on your own, try a couple more. All you're trying to do is find the formula there. Let's skip that for now, though, and get to the example 5 and 6, which kind of go together. So yeah, let's go ahead and look at it. All right, so example 5. I'm going to leave A for you guys because it's a little bit easier than well, I guess maybe not, but yeah, it's maybe a little easier than B. But let's start out with C, okay, and then go from there. All right, so looking at C, how can we fill in the blank here? This one you may be able to figure out on your own, but let's kind of take more of an algebraic approach, all right? So what they've given me here is a sub 1 and a sub 3, and they're saying find a sub 2, find the second term, given the first and the third term. So an algebraic approach would be kind of look like this. We can set, plug in our third term here, right here. So that would be 7 equals a sub 1, which is 28. You always want to leave your a sub 1 for there because that's where it goes in the formula. All right, so 7 equals 28 times r to the power of n minus 1, right? So remember, this is a sub 3, right? So so this would be 3 minus 1, or 2, right? So, bless you. So then we have 7 equals 28 r squared, and then we can just solve that just algebraically, right? So divide both sides kind of by 28. Bless you. And that's going to give me, I'm going to write it as 1/4. You could write it as 0.25. That'd be fine. And then we square root both sides from there, okay? So the square root of 1/4 is 1/2, or the square root of 0.25 is 0.5. And then we also need to remember, when you take the square root or any even root, what do we need to use? Anybody remember? Not just 1/2, but what? Plus or minus. Remember because the square root has 2 roots, right? So when I take the square root of both sides, I get plus or minus 1/2 is r. Okay. So is that what goes in between the 28 and the 7? No, right? That's what we can use to get from 28 to the next one. Okay. So yeah, just 28 times 1/2 would be what? What's 1/2 of 28? 14, right? So yeah, 14. Or technically speaking, it could be negative 14. Okay. So I'd put or negative 14. On Math Excel, they'll say, like, they might say what are 2 possible options. So it'd just be the positive or the negative. Okay. If like Math Excel will specify, it might say what are 2 possible options. Or sometimes there can be one, which we'll get to that in a second too. So yeah. All right, so let's do B together, and then I'm going to have you guys do 1. All right, so this time it's a little bit tougher, right? They give me a sub 1. They give me a sub 5, right? So they skipped a couple there. And I doubt you would come up with this on your own, right? So you got to have some kind of algebraic approach. So we'll go a sub 5, or 144, equals a sub 1, or 9. Times r to the 5 minus 1. I'm just going to write 4. So 144 equals 9r to the 4th. All right. So we'll go to solving it. So 144 divided by 9 is going to give us 16. So this time we would need to take the 4th root. What do we think the 4th root of 16 is? Anybody know? 2, right? But here's how you type it in, though. Good reminder. Any of your higher roots, you can type in the root, which is the 4th root. Go to math and use that x root, which is the 5th option. Okay, that's the 4th root of 16 is 2. Okay, so you can get some help from your calculator there. The 4th root is also an even root, just like the 2nd root, so we could use plus or minus here. All right, so that means that if it's positive 2, then 9 times 2 would be 18. 18 times 2 would be 36. 36 times 2 would be 72. Okay? And then 72 times 2 would be 144. Now, you know, the only other way it could go is if it were -2, you know, that could possibly be -18. 36 would have to be positive either way, and that could be -72. Because that pattern works too. All right. Okay, so these are a little bit tougher. So I want you to try one on your own or with your neighbor. And so you're filling in 2 blanks here. Okay, 2 blanks. So just do your best. 2 blank blank -54. All right, so I showed you kind of how to set it up. If anybody feels like they correctly did that and solved for R, can anybody tell me what R is to start? Yes. All right, now R is -3. R is not plus or minus 3, right? R has to be negative in this case because notice we end up taking the cube root of both sides, right? So remember, odd roots only have 1 root. It's either positive or it's negative. It's not both, okay? So it is -3 here. So now we know we just multiply by -3. So 2 times -3 is -6. -6 times -3 is +18. And then just to make sure it works, 18 times -3 is -54, okay? All right, any questions on that one? Okay, so let's finish up with example 6 real quick. And this is kind of a shortcut to what we just learned. And I'm sorry if these aren't on the same page, but this graphic right here is supposed to go with, so I think it is messed up. So you may want to copy this. So let's just say on this side, let's just rewrite it by hand. So the geometric mean is what they call this, is plus or minus the square root of x times y. And that's on the next page, again, just a placement error, so that's why I rewrote it. So I would also highlight this. This only works for, or it doesn't work if you have more than 1 missing term, okay? So this only works if you're bridging the gap for 1 term. All right, so look at A. A should look familiar because we've already done it. It was C for the last one. So we know really that the answer is, you know, plus or minus 14. We've already done it. So let's just see if this formula works, okay? So the formula is plus or minus x times y. So x and y are just your 2 numbers. So let's go ahead and use that formula. Like I said, see if it works. So plus or minus square root of 28 times 7. Let's see if that really gives us 14. If it does, we can feel good about the formula. So that would be second x squared to get that, and then 28 times 7. And it does give me 14, right? So again, this is a shortcut, but it only works if you're filling in one term, okay? So since we're a little bit low on time, I'll just have you guys finish B, C, and D, and I will write up the answers so you can check them. If we run out of time, you can check them on the filled out notes. But try those real quick. Your homework will be posted, but you can also save it for tomorrow because I'm going to give you the class to work on, okay? All right, guys, so just so I get it on video here, and for anybody who actually tried these, I'll go ahead and just write up your answers. We won't really have time to follow up, but we can do that tomorrow. So if you did B, you should have gotten plus or minus 3.75. C would be plus or minus 4. And D would be plus or minus 12. All right, so anyways, that is that. We'll go over it tomorrow. Feel free to work ahead if you like, or wait till tomorrow.